Solar panels and cactus biogas. We are bringing two very different worlds face to face: biological or chemical energy, biomass, and direct physical energy, photovoltaic. Both options are excellent renewable alternatives, but they work under completely different logics, efficiencies, and spaces. Energy efficiency and performance. The most drastic difference between the two is in how much energy they manage to capture from the sun and transform it into usable electricity. Current commercial panels, silicon, have an efficiency of between 15 and 22%. They capture photons from sunlight and convert them directly into electrical current. To generate 1 megawatt of power, approximately 1 to 2 hectares of land are needed, but they only generate during the day 25% of the time. In a year, if you install 1 megawatt in panels, they deliver 2,190 megawatts of electricity. The cost of building a 1 megawatt photovoltaic plant ranges between $1 and $3 million per megawatt, although in simple installations with profitable products it can start from $1 million. The cactus is an extremely efficient photosynthetic plant for an arid zone crop. It uses the SEM pathway to avoid losing water, but the efficiency of the plant's overall photosynthesis is around 1 to 2%. From that, you must subtract the energy losses during the anaerobic fermentation process in the biodigester and the subsequent burning of methane in an engine to generate electricity. In summary, solar panels are more efficient per square meter at generating direct electricity than the biological process of the cactus. Nopal biogas. As it depends on the growth of biomass, it requires much larger areas of land. To constantly feed a biodigester that generates 1 megawatt, you could need approximately 70 hectares of cactus cultivation to produce 1 megawatt of electricity 24 hours a day, 365 days a year, depending on the planting density and harvesting speed. The investment is $2 million. It will produce 8,760 megawatts per year. This is 4 times more than solar panels. Availability and storage. The great advantage of Nopal solar panels. They are intermittent. They only generate energy when there is sun. If you want power at night or on very cloudy days, you necessarily depend on expensive batteries, such as lithium ones, or the support of the electrical grid. Comparative table. Nopal biogas. It is dispatchable and storable. The cactus is harvested, digested, and the resulting methane gas can be stored in tanks. This means you can turn on biogas generators at 3 a.m. on a stormy day or when grid demand is highest. It works as a base power plant. The environmental and social impact. It's not all electricity. The context of where each technology is installed matters a lot. The Nopal as a social engine. Growing Nopal for biogas, a highly developed model in countries like Mexico. It creates direct agricultural jobs. It does not require constant irrigation water. It survives on rainwater and semi-dry areas. And the residue left after removing the gas is an excellent organic fertilizer that returns to the earth. Additionally, it cleans the atmosphere by absorbing carbon as it grows. If you need clean, cheap, and fast electricity for everyday use, solar panels gain efficiency. The solar panel as a pure clean technology. It does not consume water, does not generate odors, and has a useful life of 25 to 30 years with very little effort. However, it does not produce the circular economy or the agricultural employment that biomass generates. But if you are looking for community development in arid areas, low cost of production and investment, continuous and controlled supply of energy, fertilizers for agriculture, and backup power that works day and night without depending on expensive batteries, cactus biogas is a brilliant ecological solution.